Hi, this is your Professor Sudha Kolathu Parambil. Application Uninhibited and Limited Growth Models. Let's do an example. Between 1980 and 2016, the number of application of patents and grew by about 4.7% per year. That is n prime of t equal 0.47 of n of t. Find the function that satisfies this equation. Assume that t equals 0 correspond to 1980 when approximately 114,000 patent applications were received. Estimate the number of patent applications in 2025. Then we need to estimate the rate of change of the number of patent application in 2025. A function f of x satisfies this equation f prime of x equal k times f of x if and only if f of x equal c times e power k times x. So if you compare this equation with this given one, instead of n prime of t we have f prime of x. Instead of k we have this constant. So k is 0.047 and n of t is f of x. So it satisfies this equation if and only if I can write that is n of t equal let me write down the equation first, then it will be easier to write. F of x equal c e power kx, right? So instead of that we have n of t equal c, we don't know that, k is the constant 0.047. Instead of x we have t. So this is a function in terms of t, and where t equals 0 correspond to 1980. So t equals 0 means when if I substitute 0 for t, I'll get that is c times, this is given, right? When t equals 0, it is approximately equal this value. So we can set this equation equal to that value. So this is e power 0 equal 114,000. E power 0 is just 1. That means c equal this value. So we got the constant. So now we can rewrite the function. So n of t equal, replace c and k in the function with the values, the constant. So we will get the function n of t equal 114,000 e power 0.047 power t. So we answered the first question, find the function that satisfies this equation. So we find the function n of t, and n of t actually we have k and c, but k we already find that from here, and c we find that with the given condition, because when t equals 0 this whole thing is equal, this equation is equal 114,000. Now we need to estimate the number of patent application in 2025. If t equals 0 correspond to year 1980, we need to find t if the year is 2025. So we can actually take the difference between the year 2025 minus 1980. So t correspond to 45. So we need to find n of 45. I copied the answer for A here, and for B, first we find the difference between the years to find the corresponding value of t. So t equal 45. So find n of 45. So in the above equation, replace that t with 45. Enter this into the calculator to find the corresponding value. So while entering into the calculator, make sure you put the parenthesis for the entire exponent. So in order to enter the exponent, depend on which calculator you are using, you can use the caret sign like that for the exponent. Then 0.047 times 45. That whole thing should be in the exponent. So use a parenthesis around that. So I can round the value to a whole number, and this is my final answer. Therefore, we can conclude that the estimated number of applications in 2025 is approximately 945 and 13 applications. In part 3, we need to estimate the rate of change in the number of patent applications in 2025. So rate of change. So we need to take the derivative of this. Then 2025 t correspond to 45, right? Then find n prime of 45. So first we will find the derivative of this, then find n prime of 45. But you can see that we already have n prime of t here, so we can directly substitute 45 here, right? Or if you want, you can take the derivative of that. You will end up with the same function, then substitute. Both will lead you to the same answer. I'm going to use the previous equation because then I will have less work. So I'm using that formula. So n prime of 45 is 0.047 times n times 45. So 0.047 n of 45 is, we already found that in part B, right? So I can directly use that value. Then use the calculator and find the answer. We can round this answer to the nearest whole number. So since 6 is after decimal, we have 6, that's a number greater than 5. So add 1 to the previous digit. So we can conclude that the estimated rate of change in the number of patent applications in 2025 is about 44,416 applications per year. Let's do an example on limited or restricted growth. Suppose that a company introduces a new computer game in a city using television advertisements. Surveys show that P% of the target audience buy the game after X ads are broadcast, satisfying this equation given below. First question is, what percentage buy the game without seeing a TV ad? That means without seeing a TV ad means X equal 0. So find P of 0. So replace this X with 0 and calculate. So P of 0 equal 100 divided by 1 plus 47 e power negative 0.19 times 0. That is 100 divided by 1 plus 47 e power 0. E power 0 is just 1. So it will be 100 over 1 plus 47. That is 100 over 48, which is approximately equal to 0.08, or I can say it is equal to 0.1. Since P is in percent, I can say 2.1%. Next is, what percentage buy the game after the ad is run 18 times? That means X equal 18. So find P of 18. I replace this X with 18. Now enter this into the calculator. Make sure you have a parenthesis for the entire denominator. So 100 divided by, then use the parenthesis, then enter this whole thing inside the parenthesis. And also make sure this whole thing is in the exponent for E. So you need a parenthesis for that whole thing in the exponent too. I got the answer 39.4%. Part C is find the rate of change. That means find the derivative of p of x. I can rewrite this function as constant, and this whole denominator I can move to the numerator. If you are not comfortable with dealing with negative exponent, I suggest you to use the quotient rule. You will end up with the same answer. This is constant time function. So the derivative will be constant times derivative of the function. So it will be constant is 100. Derivative of this one, I'm going to apply the power rule first. So subtract 1 from the exponent. Inner function stay the same. Then multiply by the derivative of the inner function. That is the chain rule. So first I applied this rule like x power n, that is n times x power n minus 1. That is the rule I used. Then I'm using the chain rule. So derivative of 1 is 0. Then again 47 times derivative of e power u is e power u only. Then multiply by the derivative of the whatever in the exponent. So derivative of this one is negative 0.019. So let me explain you the rules once again. Derivative of u power n is n times u power n minus 1 times u prime. You can think like that. Instead of x, if you have a function of x, that here u is a function of x, then apply the power rule first, then multiply by the derivative of that. If it is e power x, derivative is just e power x. If it is e power u, then it will be e power u times u prime. That is what we did here. This is e power u times u prime. Let me explain you the derivative again. Constant times derivative of this function. So bring the exponent in front of that and subtract 1 from the exponent. So inner functions stay the same. Then multiply by the derivative of the inner function. So derivative of 1 is 0. Derivative of this whole thing, this is again constant time of function. So it will be constant times derivative of the function. So constant times derivative of this one is, we are applying this rule. So e power, it will be the same, then multiply by the derivative of whatever in the exponent. Now this will have a negative exponent, negative 2. So move this whole term to the denominator so that the exponent will be positive. So next step I have 100 times negative 1. Other one, I'm moving that whole term to the denominator. Then I have 47 e power negative 0.19x times negative 0.19. So I can actually multiply these constant and I will get 893 e power negative 0.19x and the denominator negative 19x whole square. So this is the rate of change of p of x, or we can say p prime of x. Part D is sketch the graph. In part A, we got p of 0 equal 2.1 and p of 18 equal 39.4. So we can think this as an ordered pair 0, 2.1 and 18, 39.4. And we can check what happened to the function when x is approaching to infinity. To look at the end behavior of the graph, so if you have e power u, it will be a increasing function. If it is a negative exponent, e power negative u, it will be decreasing function. Here the exponent is negative, so it will be a decreasing graph like this. So when x is approaching to positive infinity, this graph is getting closer and closer to the x-axis, Or in another words, we can say this graph is getting closer to 0. That means this whole thing is approaching to 0. 47 times 0 is 0. So it will become 100 divided by 1. That is just 100. That means the limit of this function when x approaches to infinity is just 100. We can graph this. This is x-axis. This is p of x. This graph approaches to 100, right? So there will be a horizontal asymptote when x is approaching to positive infinity. The graph gets closer and closer to this line, that is at 100. And we know 2 points, 0, 2.1, that is 1 point on the graph. Since this is, I marked 100, so I'm approximately saying that is half of that, that is 50. So I need to plot the other point, 18, 39.4. So maybe 18 is here. I'm approximately plotting that, and 39.4. That's why I'm writing the coordinate next to that, because I don't have the graph paper, right? I'm going to graph it approximately. So it will be like that. It is approaching closer and closer to that horizontal line, 100.